I gave you this problem, and I told you that iron would be oxidized and silver was reduced, and then I asked you to do the math. We gave you plenty of time because then I talked about useless information for probably 7 or 8 straight minutes. So hopefully, it's also my favorite thing to do, sadly. So let's check this stuff. By the way, who left their Tim Tebow book here? It's on top of an AP chemistry study guide. Okay. You could, if you're all laughing at Tim Tebow, but don't know. All right. Cute. I don't have my spandex on underneath. Oh. Good choice, though. All right. So, from the tables, what was the value for Fe? 4.4? And what was silver? 0.80? Yeah. Fine, let's go back and check. It's okay. I didn't write anything down. No, I ain't. Diane, will you please invite me to any party that you have caffeine at? Oh, crap. I just dragged that. All right, hold on. I'm coming back. That's for future reasons. Okay, so when we come up here, we take red cathode minus red anode. So we take these values, cat minus N, red cat. So we take 0.8. Oh, I'm still in that. Minus 0.44, right? Equals. Okay, there is a unit of these. It's a volt. Did that seem very difficult? Okay. If this is a positive value, which it is, then this is written correctly. If we got a negative value, we would have had the cathode and anode backwards. So when I wrote these out, I just got lucky, sort of. Okay, so these are fairly simple. Okay, so the steps to do these essentially: determine cathode and anode. Use table to find values. Subtract. I already forgot. Anode, right? Yep. Anode from cathode. And use the unit of volts. No, you won't always get a positive, but most of the time you should. Because you could get a negative and then it could ask you what that means. And that would mean that it's non-spontaneous, essentially. Good morning. Saw you about an hour ago leaving. I thought you only worked out on Mondays. Ugh. Okay. Are we okay with this? Do you want another one, or are we good? Okay, we'll do another one. I'll do it on the table. All right, so let's say we have, oh my, whoever you are, Buck 1096, I'm going to kill you. You're in this room. You are in this room. Kieran? Yeah, it's always the quiet cheerleader type. So you have a cell made up of silver and Ag, but I'm not telling you where the cathode and anode are. You can, what did I just say? Oh, sorry, and lithium. All right, based on what I just barely said, see if you can figure out where the anode and the cathode is for it to be spontaneous. Okay, it has to end up being a positive value. So what are these numbers? We have negative 3.05, right? And a positive 0.8, correct? What combination makes this subtract to be a positive value? This is the only way to make that work, correct? All right, which we have cat minus and, do we not? So this would be my anode. Sorry. This would be my cathode. This would be my anode. Then it wouldn't. Yes, but it wouldn't. Yeah. We can pair whatever we want, but we can get higher, or sorry, the values get smaller, and they can also pair non-spontaneously, but that's just pointless. Are we okay with how this was figured out? Yeah. So what does this end up being? 2 point, or that's what I meant. I'm not, hey, I had a rough morning. I had to listen to Diane's sugar binge. Up where they talk. I don't know the next line at all. No, poop. All right, so try these real fast. I will go back. So write them. Nope. Can I give you a U instead of an H? All right, so here we go. H is 0. What's F? All right. So here we have whatever. The E of the cell is equal to the cathode minus the anode, right? And it needs to be a positive value, right? So which one is which? 2.87 minus 0 equals 2.87. So it's really nice. It's really nice when we use hydrogen, right? All right. So, muchas bueno. Hey, if we, I feel like I'm talking. I do get annoyed sometimes, legitimately. If we could make a battery that had fluorine in it, what metal would we want to pair with it from our list? Lithium. It would be super vigorous. Why is that a funny word? Was it lithium 3.0 something? Okay. If it was safe, what would we end up with? Our voltage. Okay, I have officially gotten annoyed. I've reached my meter. Okay. Not mad. Mad. It's a meter. Have you never seen a meter thing? Why are you mad? When I talk, you listen and or at least be silent and play on your phone. At least respect me that much. Okay, so here we go. If we wanted the highest voltage possible, if we took fluorine And lithium, actually lithium's not even going to be, it would be cesium, but we wouldn't make that battery anyway. This would be 5.92 volts. That'd be a pretty strong battery. So here's a question. How do we get a 9-volt battery then? Boyd's right on this one. A 9-volt battery, there's no way on the planet we would make a battery with fluorine and cesium. Like if it cracked at all, kaboom, like it could kill you. Okay? So this isn't an option. We take a battery, and it's 1.5, I don't remember which ones it is, but we put a bunch of 1.5s in series, okay, and they add up to 9. So if you get 6 1.5 cells and put them in series, their voltage adds. There's a fancier word for it, but I can't remember what it's called. Anyway, that's how we get higher voltage, not necessarily these. But anyway, okay, let's CU and BA. What did we end up with? 2.14. That's just terrible. 2.34. Are we mocking Rockettes because there's one in the room? Yeah. She will. She's a pretty good dancer. You're one of the few that you can kind of tell who you are because your hair's blonde sometimes. Yeah. You can find the 2 Rodriguez's and Tim Bimbo because she's 6 feet tall. And then everyone else? Who are you? Yeah. What is it? What is it flavored like? AU, actually. Oh my gosh. All right. Oxidizing and reducing agents. We actually talked about this in chapter 4. But as Hunter eloquently put it, I'm not going to remember any of that crap. Right? So here we go. The strongest oxidizers have the most positive reduction potential, and the strongest reducers have the most negative reduction potentials. An oxidizer is something that helps reduction happen. A reducer is something that helps oxidation happen. All right, so if we look at this, all right, so lithium here, try to get them both. Oh well. Lithium's down here. We knew lithium was at the bottom of our list already anyway. It's the strongest reducing agent. All right, meaning it helps oxidation to happen. All right, this is the strongest oxidizing agent, which okay, so the strongest oxidizing agent means it's the best reducer. Okay? And reduced means to gain electrons. It should make sense that fluorine is the best gainer of all electrons. It's got the highest electronegativity. All right? The strongest reducing agent means it's the best loser, which would make sense. Anything in family 1 or anyone in first hour AP. Just kidding. Just because you did what you did to me, which was hurtful. All right? They easily lose electrons, right? They easily do. Okay. Be all right with that? Hydrogen's roughly here in the middle, and that's why it is used as the standard. Don't even think about it, Port. I already said, but make sure you know that. Uh-oh. Worst check mark of the year coming up. What's stupid? That is so hurtful. We've been through a lot together today. Yeah. Okay. Hey, shh. Remember how we talked and compared these to waterfalls? The larger the fall, the greater the energy of that water, right? Okay, smaller the fall, the less energy. Yesterday, I got to teach my daughter about intensive and extensive properties. Because, yes, so think about this. Let me pause it. No, she didn't. But anyway. Okay. Hey! Yay! All right. This is a thing. Okay, we've mostly spent today doing hardly anything. I don't know why this is an X. It needs to be gone. Okay, mistake time. That's why we can... Yeah, I was about to say something dumb. Okay. Delta G for a redox reaction can be found by using the equation delta G equals negative NFE. What is E? Nope, it's the E of the cell we've just been finding. Well, entropy wasn't E. Neither was enthalpy. Maybe. Okay. Where N is the number of moles of electrons transferred and F is the constant, the Faraday. 1 Faraday. Oh my gosh, I'm going to kill someone. 1 Faraday is 96,485 coulombs per mole, or 96,485 joules per volt mole. Okay, that's a number you're going to have. That's it. They're definitely gone, people. You've gone too far over there. It's Agrin. Look at him. He can't even maintain it. It's all right. So this is an important thing. When it says the number of moles of electrons transferred, that's this number that we would find when we found its oxidation and reduction things. So this is hard to see, but if zinc goes to Zn plus 2, there were 2 electrons transferred. That is your N value. I didn't mean to really point either way or the other. I was just connecting them. Okay. So that is your N value. You okay with that? F is this value, which is a constant, which is nice. It is given to you on the AP sheet. 96485. All right. And so E, that's just what we've been calculating, which a minute ago I said, are you okay with that? And you all said, yeah, I think we're good. Right? Yep. Which part? E. Yeah, E is this thing we've been doing right here. It's the E of the cell. Okay. Under standard conditions, delta G naught equals negative NFE standard. Jeffrey's still laughing at something. Something's happening. There's another comment about to drop. All right. So it looks like I gave an example right there, so I should give another example. Okay. So Fe plus O2 goes to Fe2O3. Find me some delta G naught stuff. So you're going to need iron and oxygen. I will go back there in just a second. And iron's tricky. What's the oxidation? What's iron's charge here? Plus 3. Because in the table, iron, what's the word I'm looking for? Iron has a variable charge, so you'll see it as a +2 or a +3, so you got to make sure you choose the right one. Okay. It is. And to balance it, it's a 3-2 swab. Oh, boy, is right. By the way, when you balance these, that matters. Let's do it real fast. So -2, so that's their charges, 0 and 0, right? But then to balance it, you need a 3 here, a 2 here, and a 4 here. Whoops, a 4 there. It is. Yeah, it's how I learned how to cheat in 8th grade. All right. Well, your math, you said it was 2, and they're like, the answer's 4, and you're like, I know it is. Okay. All right. Now, look, we have to identify what's changing. So Fe went from 0 to a +3. So did it become more negative or more positive? More positive, which meant it was oxidized. And how many was it? It went from 0 to a 3. So it lost 3 electrons. But we need to be careful here. And I'll tell you why in a second. O became more negative by 2. So it was reduced, which means it gained 2 electrons, right? Do these equal each other, 3 and 2? No, they have to, but that works when we do the balancing. All right, we had 4 irons lose 3, correct? All right, and then you got to be careful here. We have 3 times 2, which is 6 oxygens, gaining 2. Does that equal each other? Yes. All right, so we have to do that, and then we have to be careful. The moles of the electrons in this equation are 12. Okay, that N value is 12. All right, and this one you should not have. I'm sorry, it's my fault. And this one was 12 also. You okay with that? So you have to use the coefficients when you find this N value. Okay, then go back here and find our numbers we're going to need. So Fe plus 3 is here. And oxygen. Nope, that's water. Not that ultraviolet. No, it's not. They're all a little bit different than what we're looking for, but whatever, I don't care. Let's choose that one. Okay, I'm going to go back to the other page. You ready for the other page now? All right, so for Fe, we found it to be what? What's that? 0.77. For O, we found it to be 0.4, negative 0.4, positive 0.4. It's okay. All right, so we need this to equal a positive value. So I'm going to take 0.4. No, I'm not, because that's a positive still. Oh my. 0.77 minus 0.4. 0.37, correct? All right, and now we plug this in. We have delta G. Okay, not working. Delta G equals negative 12. Where did I get that from? From these. That's the number of moles of electrons. F is 96485. And this 0.37, right? We end up with delta G equaling what? Wow. Does that number seem ridiculous? Yeah, but it's joules, so it's not really. It's 428 kilojoules. Negative, by the way. Does negative matter? Yeah, it does. Why is it negative? Because it's spontaneous. Okay. This negative sign is one thing that helps us prove that really this answer needs to be positive if it's really working as written. Wow, I feel like such a hero because that was such a great lesson today.